Well, one of the things we've done in our laboratories, we've pioneered a new way to analyze and deal with nuclear magnetic resonance experiments, in particular NMR imaging. The first area I call system and parameter identification. So it's the idea that there's principles, or science if you will, that has to do with the best choice of equations and properties within equations to describe physical phenomena. So this is a particularly good tool for people who like to try to describe physical processes with mathematics. The second area is flow in permeable media, and this has been an area of long-term interest to me, and we've worked a lot in areas of petroleum production or even aquifers, but many of these principles apply to all sorts of permeable media. In fact, if you look around, permeable media is practically everywhere, and much of the human body is composed of permeable media. So that's part of my current focus, is trying to bring some of these things that we've developed in different areas into the human body, into things like tissues and bones and other things. And one of the reasons that I've really worked with permeable media and modeling permeable media for so long is it's so rich with system and parameter identification problems. The third area is nuclear magnetic resonance and both imaging and spectroscopy. This is a really unique instrument that allows you to get information non-invasively inside materials and inside media, and so it's really natural for a person that's interested in both the other two items, permeable media for one, in that you can get information inside now as a change, but once again it's also very suitable for these system and parameter identification problems, because you want to use those measurements to get useful information. What we have done is establish a new paradigm for dealing with MRI, and we are now beginning to bring these into important biological processes. So as we initially look at things like bone and flow in bone, skin and cartilage, but more and more we're going to be interested in modeling the actual biological processes. And I think that the sort of opportunities here are immense, because biology is so complex, and there are yet to be developed better and better descriptions of biology, mathematical models of what's happening in biological processes. And all the time, the tools we use, such as system and parameter identification and NMR, will be the types of things which will drive these models forward, so that we can develop better and better descriptions of physical phenomena and biological physical phenomena.